my fellow programming engineers. Welcome back once more to this industrial network course. And we are in our second part of our DeviceNet course. I'm going to tell you that the biggest headache in DeviceNet is mapping. Why is this so wrong at an engineering level for DeviceNet? For us to be able to control and access our data from a DeviceNet network, it's a module of this time. So we would never be able to view these data. So from our DeviceNet module, or the scanner, we should be able to locate their inputs and outputs, because remember that these are at an industrial level device. So for us to remember how we're going to start up the motor, analyze if there's any failures or any flaws, we should store their input memories and their output memories. Now, why do this? Or for us to be able to translate this and send this information to our controller, it all depends on which entries or which activations we're going to view. And from then, we send our controller to activate the output memory. Now, it is a bit new for all of us, but once we understand how it works, it would be pretty simple. Okay? Now, how do we do this mapping? What is mapping? So to understand this quicker, let's open our software, RS Networks, for DeviceNet. Okay? So we open this. And let's create a project from scratch, so I can show you guys how the mapping works and what I mean by this. Actually, in our visual part for Ethernet, it's very, very similar. But we should see here on top that it's for DeviceNet. So let's look here in the port. So let's look for this. So this is a scanner, but for a different style. So now, let's look for different compatible devices with our communication network DeviceNet. So in this case, we're going to select a PowerFlex 750. Should be here on top. I think I'm overcomplicating this. Okay, here we go. 750. So I'm going to select this, and I'm going to send it to this side. Okay, so I already have my first device. If I open its properties, then here I would be able to change its node. If it's from 0, I'm going to change it here. But that's why it's much easier on this side, which was what I had told you. Okay, now the parameters, here is where there's many questions that arise. You should have already identified your devices for DeviceNet. Now, let's suppose that I already have my 757 device, and I know that this is compatible with our DeviceNet. So this is where they ask us for our mapping. But which type of mapping? My I/O mapping. Okay. Here, for example, it's indicating us inputs and outputs. For what? For my PowerFlex 755. So it's telling me then that the first 4 bytes are for my logic status, and the following 4 bytes within our inputs is our feedback, or my encoder. Because this drive is for motion, but that's optional. What isn't optional is our logic status. And on our bottom part, we have our first 4 bytes, we have our logic commands, and the next 4 bytes are to indicate our reference. But what type of reference? This is speed reference. Okay? Then we have our cosine. And this, we're not going to touch this. The cycle part, it's the same way. But what we're mostly interested is in our pult. So this, to get our general data from our I/O. So the cycle and the cos, the cosine, it's pult. Now I'd like us to analyze something else. Now I have a document here. So depending on the device for our PowerFlex, they should open up their manual or their Allen Bradley device, which in this case, we should look to see how our memory, our internal memory is, in this case for my I/O, just so that I can map it out to my scanner on my DeviceNet, which in this case, if you see, I can see for my data, for my I/O data, that the first 4 bytes are logic status. Now, if I go here to my word in my logic status, then I'm going to find these parameters by default. Okay? So then, when I have for my first beat for that word, when I get a 0, then that means that my drive is not ready to be run. Or if it's at 1, it means that it's already ready to start, okay, or to be run. So beat number 1, I'm going to have it as if it was in 0. It means that it's inactive. But if it's 1, it's active, and so on, and so on, and so on. And that way I'm going to be able to get the information for that logic word for my status, for my Lotus, sorry. Now, this is what it means. Because this is why the input, because this is what I'm getting from my drive. This is its status. And then we have our logic command, which is up here. Now, this is where the magic happens. This is by default, and this is internally in our PowerFlex. It's already completely established. Now, if I send out a 1 to my logic bit, to my logic beat 0, if I set it to 1, then this means that it's going to stop normally. If I send out a 1 to my bit 1, then this means that I'm going to start it. If it's a 0, then I'm sending it off start. And I got the same thing, for example, for beat 3. I can clean up the failures via communication. Now, what do I mean by communication? By this, I mean that my file or my program for Studio 5000, I am going to create a new module. Okay. So that's 1756 DNB, which is a DeviceNet scanner. And you're going to notice this for the version number. And here I'm going to add the name as a scanner. Now, which slot number? Depends on which one is going to have my scanner device. Remember that we can change it directly from my hardware. Let's suppose that it's number 1. So here we say OK. And here, if you check this out, it's going to give us a max input size and output size. And also if we want status size. But this status is already set by default. Now let's suppose that I wish to create, let's see on this side. Let's suppose that I want to create 20 words for 32 bits and 20 output. So here we already created everything automatic. And now we're going to look for our local because this is for our local chassis. So let's see here. Let's see if this is true. Controller tags. And here we are. For input and for output. Okay? Now, how many did we create here for words? This is a double integer. There's a double hole. So we created 20 words, okay? So if automatically we are being indicated here for my RS networks that this is a logic status, the first 4 bytes, how many bits are a byte comprised of? 8 bytes. If it's 4, then this is 34 bits. And how many bytes is a double integer comprised of? 34. So one only double integer is already helping us out to get our logic status or our logic command. Okay? Do you see this? Now, if I go back here, this is the same manual, by the way. But if you look at this, I can send out to analyze that my input, the first word is a logic status. And I go here. And here, I'm going to make this smaller. Now here, for description, I'm going to add this. Logic status. Okay? And then what else is it saying? Automatically, it's saying that it has some feedback. So speed feedback. Okay? So logic status, let's see what it says here. Here we go. And on our other double integer compound is a feedback for velocity. So this is speed feedback. And if I go now to here on this side for my data, okay, what is it indicating as an output? That's logic, comma, okay. And on the other side, we already have the reference for velocity, for speed. Speed reference, yeah? So everything that has to do with output is what I am going to be able to modify in my drive. Okay? So speed reference if I wanted to run at 60 Hertz, which is its top speed, top speed, I'm going to add here to my double integer a 60. Okay? If I want to send it out to start, I need to analyze the words or the wording, my bytes. This is my command word. Now let's suppose that I wish to start this out. Okay, then I select my word on this side, and I'm going to create a logic. Okay, so let's create this. Add new routine, R02, start, motor, DeviceNet. All right, done. So I'm going to send out OT, here we go. So we're going to use slight logic so you guys can see how this works. So logic command. It's point 1, let's see what it says. So I'm only selecting my byte for my word logic, comma. If I wish to add here for my 1, or in number 1, the start, then in that case I should select this one. Okay? And here in this line, Control D, have it start from my motor start forward DeviceNet. Okay, so motor start, let's say line 2. Something identifiable from that motor. From this, I'm going to add a physical button or an HMI button, whatever you guys need to start the system. Okay? So then, this is our DeviceNet technology. We confuse this because we need to map it out, but we only need to learn how to get this data. That's it. Here, for example, start, motor, HMI. When I start this, it's going to send out my command directly to my scanner. And from my scanner, it's going to send that command through the backplane to my processor. And my processor, again, is going to go back to the scanner. And from the scanner, it's going to send out the signal through communication. Where do you guys think? To my drive. Exactly right. Or my PowerFlex in this case, which is the 755. Okay? Same thing. If we wish to get information and the current information reference, or my feedback, let's create a new line here. So let's view. Now, what is the feedback here? Let's see here. So controller tags. And the feedback that I need is this word actually, which is local 3 point SI data 1. Okay, so I send it out here. And here I can visualize. Visualize through an HMI button. So speed or motor speed. Or actual speed motor line 2, which is this one. So I'm going to create a memory, and this one I can link directly to my HMI screen. So whatever I get for speed is going to be, you're going to be able to see on this side. It's pretty simple. So I'd like to create a new parameter without a problem. So all I need is to analyze and run the data links that I would be able to get through my DeviceNet communication. Okay? How do I get these data links? Well, that's a different topic for the drives part. Okay? Now, those data links, I need to say, so the parameter in this case, let's see here. Let's search for these. Let's see here. Where are our parameters? Okay, so parameters are for our messages, but they should be here so they can view them. So I'd like to show them, because here, they could be here actually. Our data links, I can get them directly through, or from my CCW software or my workbench, from Drive Explorer, or directly from Studio 5000. Okay? Now we have to assign, because we are going to look into the data links, or 02, which is a predefined word. And I'm going to say, well, I want that the parameter that we get from this is 527. So here in this case, it's set as 371. Now analyze the parameter list. If it looks like this, and check to see which parameters are the ones that you're going to identify as data link 1. For example, net01. So which parameter do you need here? It needs torque, it needs application type. Now this is a little bit deeper and larger, but for you to keep in mind for your drives course, you'll notice that everything was explained correctly. However, this was in a DeviceNet device. Okay, they use our PowerFlex quite a lot. However, if all you want is to control velocity, start, stop, acceleration, and deceleration, then only through our logic command word can you control whoever you wish. Now also, if you'd like to monitor your data, your velocity, and what the velocity is that you need or that you're using, so logic status word, you can monitor from the most essential part. If you want extra parameters, then what you need is to review the data links and start adding it there. So the data link, what is it that you'd want us to do? So that word, you're going to have it here mapped out, okay? So when I'm not sure if when you call it out or send it out, logically you're going to be able to run the drive data transmission or through our computer. Okay, it's easy, right? All right, so with this, guys, we're done with our programming part. As I said, it's a bit complicated, but we just need to find a way. So if you have a DeviceNet sensor, check the manual, which is what I recommend. Analyze the manual, analyze the parameters that you could get for input and output, and check to see how to locate them in our scanner. Analyze the words that you're going to get when uploading them, and start writing your comments. For example, if I want to add torque parameter. Okay. Now, what does this mean? What is this? You know, start grouping your memories, and you're going to be able to control them. Okay. So with this, we're done with this class, and I'll see you guys in our next one. Big hug, guys.